Starting this. So make sure everything's working. So make sure everything's working first. I think everything is working. But I'm gonna grab my subtaxer viewer. All right, got all of our stuff. And move the chair out of the way. So I'm just gonna end up standing in Pac-Man. All right, I got a red marker and a green marker because it's December, I guess. But let's get started. So we're gonna review all of this. So we're gonna start off things with unit one. So let me figure out where I can. Right, about right there, which is fine. But I gotta pull up my stuff for this. Okay, honestly, there isn't too much to review here, other than given some arbitrary x squared plus y squared plus z squared plus uh, a x plus by plus c z is equal to d. Write this in terms of the equation of a sphere. And so we can do this by, I'm going to try and not look at my notes. I'm going to use the notes to figure out what I need to do if I'm just completely stumped. But we can group these like terms, and a sphere or an ellipsoid or whatever is going to be something with an x. So x minus a is not going to be the same a. So we'll call this alpha squared plus y minus, is it minus? I'm going to assume it's minus because a lot of things in math. These aren't angles, so I don't know why I'm using alpha, beta, and gamma, but whatever. So y minus some other things, and that quantity squared, plus z minus, I don't know, lambda squared is equal to, uh, I mean, this is actually pretty easy for that variable. That's just equal to r squared, because that is actually the radius. So if we wanted to write this, any set of numbers, then we have x squared plus ax. And we want it to, we need to complete the square to get it to be x minus something squared. So I don't exactly remember how to complete the square, so I'm gonna go over here and derive it real quick. So if we have a square of x and x, so this is gonna be area x squared. So if we have x squared plus ax is equal to b, then this area is x squared. Right there. So if we have sine like x here, because so it's gonna be x. And we broke it down like this. It's gonna be x, this is gonna be x, and we have to do this in terms of a. So this is a over 2 and a over 2. And so this area that we're gonna add to both sides is gonna be a over 2 quantity squared. So then we just add a over 2 quantity squared to both sides for a squared over 4. I think that's how that works. So if we have plus x, and so then to the right side we're gonna have to do the same thing. So I'm gonna erase this part, and we're gonna say this is the one that they did in the test, so I can just affirm everything. X squared plus y squared, y squared plus z squared, 2x minus 4y. 6z, 6z is equal to 12. 6z is equal to 12. Okay, so we're gonna just regroup these as x squared plus 2x. And then we're gonna put these in groups. It doesn't change the order, we're not multiplying anything. So again, that would be y squared plus 4y z squared minus 16 is equal to 12. So if this is equal to 12, then we need to do, I do notice that all of these are nicely divisible by 2. So if I said plus divide 2 by 2 and then square it, it's going to be plus 1 here. We're going to plus negative 4 over 2 So negative 2 squared is 4, so plus 4. And 6, we're going to add negative 6 over 2 is negative 3. Squared is positive 9, so plus 9. So we're going to add 1 plus 4 plus 9, so 5. 5 plus 9 is 14, plus 12 is 26. So we're just going to say this is now 26. So now we can factor this by saying this is going to be x plus this, x plus 1 squared plus y minus 2 quadric squared plus c minus 3 quantity squared is equal to 26. So that's the equation of the sphere. And so then this would be at negative 1, 2, 3. That's where it's located, and the radius is going to be the square root of this number over here, which is square root 26. Everything right? Yep. Lovely. Two is the vector, and b is also a vector, which is equal to negative 3, 2. So our vectors, then we want a unit vector in the same direction as a unit vector in the same direction as a. So the unit vector is going to be the vector a over the magnitude of a. And the magnitude of a, so let's just put that over here. So the magnitude of a is just going to be equal to the square root of 1 squared plus negative 2, the quantity squared, which is just going to be equal to the square root of 5. And so then u is going to be 1 over the square root of 5. So negative 2 over the square root of 5. This is a vector. Awesome. Next up. So if we need to find the cosine of the angle between the vectors. So a, I'm trying to use both of these now. So there's going to be a vector in 2D space is 4, negative 3. 4, negative 3. And b 5, negative 1. I want to find the cosine of the angle. We don't have to solve for the angle, we just have to find the cosine of the angle. So the dot product a vector a divided with b tells us that the magnitude of a times the magnitude of b cosine theta is equal to A dot B. So we can do A dot B. A dot B over here. The dot product is just 4 times 5 plus -3 times -1, which is going to be equal to 20 plus 3, which is 23. So A dot B is 23. The magnitude of A is going to be the square root of 4 squared plus -3 quantity squared, which is just going to be equal to 5. So that's going to be 5. 5 times the magnitude of B is going to be equal to the square root of 5 squared plus -1, the quantity squared, which is going to be equal to the square root of 26. So square root of 26. So 5 squared 26 times cosine theta is equal to 23. Divide everything by 5. Square root 26. So that's going to be the 23 over 5 square root 26. It's going to be equal to cosine theta. Is that right? Yes. Brilliant. Fine. Linear form of the equation of the plane. 1, -2. So 1, -2, 5. Is that a normal vector or is it a point? It is a point. So this is a point. And it's perpendicular to the line x with a 14. So this is a line here. X is equal to 4t. 1 plus 2t. Or y is equal to 1 plus 2t. So this is in parametric form. And c is equal to 2 minus t. Okay. I don't remember how to do equations of a plane. I know something about the normal. So if it's perpendicular to this line, so we have a point, and we want to find a plane that's perpendicular to this line. Well, that is technically how we do the plane. This is by finding the normal vector. So I think I can just use these coefficients as n. So the normal vector is just going to be equal to 4 to -1. So I can call the equation of the plane to be, I think it's just n. These are the normal points. So I'm going to say 4 times, I think it's x minus 1, and then it would be 2 times y plus 2, and then -1 or -1 times z minus 5. I think that's how planes work. Okay. Then this is equal to 0. Cool. This is equal to 0. And I don't know if we can leave it like this, or if we want it to be this like some standard notation. So we're just gonna rewrite this as 4x minus 4 um, plus 2y plus 4. So this plus or minus all cancel out. Minus z plus 5. 0, so we're gonna subtract 5. So negative 5 is going to be equal to 4x plus 2y minus c. Is everything right? Yep. Okay. Awesome. Next page. Oh, the components and stuff. I completely forgot these even existed. Okay. So the component of a vector B onto A. Oh gosh, I completely forgot how to do this. B is 2, 1 and A is 3, 4. What was A again? 3, 4. All right. 3, 4. So the component versus, so I'm totally blanking on this. So the idea is something to do with right triangles. I know that. This is a use of the dot product. So with the dot product, so this is theta. So now remember whatever the component of B onto A is similar to the projection of B onto A is equal to the component of B onto A, but we're going to also multiply by the unit vector in the same direction of A. So I know that this is vector B, this is vector A, but vector A stops right here. And so we're just going to project B along. And so this, now we're going to project the magnitude of B. I think that's how that works. If we put the magnitude of B here, the magnitude of B, and so then we're trying to find component of B onto A. This, the big line onto the little line, over on the line. It's got to be something with the dot product. So I'm just going to write A dot B. I know that much. A dot B, and it's going to be equal to, or over It might just be A. Is it A or the magnitude of A? Is a real question. I mean, having it be the magnitude of A makes the most sense because I remember there's going to be the bottom is going to be squared when you do the component or the projection. So the projection of B onto A. And I remember this unit vector part of B onto A is going to be equal to then A dot B over the magnitude of A times the magnitude of A times the vector A. So the projection is a scalar, the component is a vector. And this would be a vector quantity. So I think this is right. So A dot into B, so A dot B is going to be equal to 6 plus 4 is 10. Plus the equal to 10. And then the magnitude of A is going to be equal to 5. I was going to write square root of 3 squared plus 4 squared, which is equal to 25, which is equal to 5. So this is going to be 10 over 5, which is 2. And so here, we already know this bit is 2. So we're going to say 2 times the vector A, 3, 4, over the magnitude of A, which we just found out was 5. So then we have to kind of simplify this. It's going to be 2 times 3 is 6 over 5, 6 bits, and 2 times 4 is 8 over 5 is 5. So 6 fifths and 8 fifths is the projection of B onto A, and the component of B onto A is 2. Awesome. That took way too long to figure out, but I'm glad I kind of slapped it in my brain just now. I think I'm going to skip calculating the cross product, but I will do parametric equations. So we have a point P, which is 1, 2, 3. It's a point, and then Q, which is 3, negative 1, 7. Boom. So if we have these 2 points, we are trying to find the parametric equations. So 2 generic points in 3D space. That's what we have. We have 2 generic points in 3D space, and we want to find the equation of the line. But we can calculate the vector between them because, well, the equation of the line is going to be x, y, z. some vector is going to be then some starting x naught, y naught, z naught plus t times then the direction vector. So like I don't know what to call that, v1, v2, v3. So if we have the vector that's half of it worked out. So u, the vector pq is going to be equal to 3 minus 1 in the first component, negative 1, 2 in the second component, or minus 2, and 7 minus 3, because it's end minus starting in the last component. So PQ is going to be equal to 2, negative 3, 4. So that's PQ. That is these. Now, what are the starting quantities is a real question. I could just call either of these points the starting point. No, wait. These. We could call either of these the starting quantity, right? So 1, 2, 3. 1, 2, 3 plus t times the vector 2, negative 3, 4. And so then 1 plus 2t is equal to x. Y is equal to 2 minus 3t. And z is going to be equal to 3 minus 4t. So, everything right? Right. So, script is marker. Z is equal to 3x squared plus y squared. We need to figure out what this is. So, first, I see that there's an x squared plus y squared. So, this is kind of like an R thing with a rotated. So that's just saying R and then rotated about the z-axis. That's a coma. Oh, no, that's not a coma. It's a lie. I just lied. Um, it's z, right? So wait, why is it not a? Is it a cone? No, it's not. This was what is a cone? It would be z squared. So z squared versus r squared would look like some crosses, and then just like rotate, and that would create cones. So this creates. Let's see, actually, I have to draw the little like trace thingies for. So if I said, let's look at xz, this is going to look like 3x squared. So this is going to be z is equal to 3x squared. So this is going to be x is equal to 1, and then z is going to be equal to 3. And for z is going to be 1, 1, 1, 1. So then when we draw it in 3 dimensions, it's going to be one of these bowl things. Not really. It's a bowl. Elliptic because there's an ellipse. Paraboloid. It's parabolas. There's parabolas. Studying vector calculus, so I'm not really going to review it today, I don't think. Sketch the curve r of t. R of t is going to be equal to t comma t cubed. T comma t cubed. So this is the first section in our vector calculus. Not vector calculus. Our vectors kind of math and point. So we just need to sketch this vector function. That's what this thing is called, vector functions. So we can call x is equal to t and y is equal to t cubed. So then this is going to end up being y is equal to x cubed. If we substitute in t for x here. So then we could literally plot the function y is equal to x cubed here and label 5 points and call it a day. Or we could make a little table and say what the sense is. It's gonna be it's gonna be t. It's gonna be t. This is gonna be x. This is gonna be y. Okay. So then we're gonna make it do all the math. We're gonna come up with it. So for t is equal to -2, -1, 0, 1, 2. We want 5 points. So that's the question. So x is gonna be -2, -1, 0, 1, 2. Y is gonna be -8, -1, 0, 1, 8. And I can just like literally plot those. So that was for tests or views. So I'm gonna go take a tiny break for If we're ready for the next section, let's go. So we have to find the parametric equation that is tangent line R of T T plus 2. So this is a vector function. T plus 2 T cubed minus T cubed minus G and T cubed plus T. So this is a vector function. We need to find 3, 0, 2. So we want to find where it's tangent. So the first thing is I don't see an easy way to re-parameterize something as a function of x, y, and z very easily. Let's see. So this p is a point along this vector function. So if we said 0, even that wouldn't work. What if we said 1? Uh, yeah, that works. So R of 1 is going to be equal to 3, 0, 2. So given that we have a point, we're going to need to find the parametric equation things. So let's make x, y, and z. And then we have t. We already got that. So 3, 0, 2 plus t times our vectors. Well, the vector thingies says that we have some generic space curve. Or even two-dimensional curve. This is just so we'll draw one for gosh, this is negative x squared, sure. So this is negative 1. We have a tangent line there. Negative x squared, or t is equal to x, y equal to negative t squared. So like that in parametric form. So if we wanted to find, instead of the direction vector, the slope, just say take the derivative with respect to t. So y prime of t, negative 2t. Negative 2t. So that is this thing. So we're just plugging this back into uh, over here. So t times, no, let's do r prime t And this is also t is equal to 1, so we're going to write r prime of t 1, 3 t minus 1, and 3 t plus 1. So that is r prime of t, r prime of 1 is going to be equal to 1, 3, 3. No, I can't do math. It's 2, 4, 2, 4. 1, 2, 4. 1, 2, 4. So then x is going to be 3 plus t y is going to be 0 plus 2t, or 2t. Z is going to be equal to 2 plus 4t. Is that right? Brilliant. Vector functions. G. Oh, wait, that R of t? R of t. You know what? Instead of walking back and forth, it would be such a brilliant idea if I just carried the paper around with me. Let R of t equal sorry, R of t is going to be equal to 3t squared minus 2t 4t cubed plus 5t. So that is a 2D vector function. So first we want to find the unit tangent vector. So the unit tangent vector is t, capital T with a t inside. So the unit tangent vector, well, if we recall, the unit vector is just the magnitude of a over the magnitude of a. So a over the magnitude of a. Goodness. A over the magnitude of a. I write the wrong thing. So the unit tangent vector is, I'm going to assume r of t over the magnitude of r of t. So we have a t is equal to 0. So let's do r of 0 first of all. This is t is equal to 0. So it's just going to be equal to 0 and 0. Okay, I goofed it. It is r prime. This is tangent vectors. So let's fix that. Try it one more time. I was like, 0 and 0, that does nothing right. So let's try that one more time. We're going to do r prime t. So we're going to say r prime of t 6t minus 2, comma 12t squared plus 5. So then r prime of 0 is going to be equal to negative 2, 5. The magnitude of r prime of 0 is going to be the square root of negative 2 squared plus 5 squared. which is going to be 4 plus 25, which is going to be square root 29. Therefore, the unit tangent vector of t is going to be r prime of 0. So the unit tangent vector of 0 is going to be equal to negative 2, 5 as a vector over square root 29. I don't think you can simplify square root 29. So this is going to be the vector negative 2 over square root 29, comma 5 over square root 29. Yep, okay. So next we're going to write the integral of 0 to 1 of r of t. With r of t? Okay, cool. So I think you can just integrate the components. So this is going to be the integral of 0 to 1 of 3t squared minus 2t dt, comma, the second is going to be the integral of 0 to 1 of 4t cubed plus 5t, boom, boom, dt. So then we can just integrate this 3t cubed, the integral of that is just going to be t squared. It's going to be 3t squared, the integral is going to be t cubed. The integral of negative 2t is going to be negative t squared. Means from 0 to 1. And then the integral of 4t cubed is going to be 4, is going to be t to the 4th. The integral of 5t is going to be 5 halves t squared. And then we're going to have this from 0 to 1. So we can just put 1 in there. So 1 cubed minus 1 squared is going to be 0. And 1 to the 4th plus 5 halves. So it's going to be 1 plus 5 halves. Or that's going to be 7 halves. Yeah, 0, 7 halves. Great. Next up, we got find the length of the curve r of t. And this is a vector function. 2 sine 3t and 2 cosine of 3t and then t. Then from 0 to 0 plus 1 t plus 1 2. Okay. I need to find the length. So the arc length I've not done this in so long. So we're gonna add up. What are we gonna add up? We're gonna sum up, obviously, from 0 to 2 and dt. So it's gonna be some differential that we need to write in terms of dt. So if we have two arbitrary points in space and we want to find the distance, not the vector, like we did before, but just the distance that's going to be, so that's kind of like dx or something for arc length. So, because I guess for arc length we do the integral of ds from t equals 1 to from t1 to t2 or whatever. Because if you add up, here's an arc length, here's an arc length, here's an arc length, add them all up, then that should work. I think that's how you find the total length of the curve. So this should be the equals to 1. So now ds is going to be a square root. You have to do the prime, don't you? So you have to take, let this be x, this be y, this be z. So like x prime. So the ds is actually going to end up being x prime squared plus uh, y prime squared plus z prime squared dt. So x prime is going to be 3 times 6 t. Or 3 times 2 is 6. 6, because you chain rule, then derivative of sine is cosine of 3t. Um, y prime is going to be equal to uh, negative 6 sine of 3t. And then z prime is 1. So if we plug all of these values into ds is going to be negative 6 squared is 36. So I'm going to plot a 36 out of these first two. 36 times cosine 3t, cosine squared of 3t, plus sine squared 3t, and plus 1. So I don't think it matters what's in the argument, as long as the argument is the same, so 3t, 3t. So this is just equal to 1. So this is just going to end up being, so ds is going to end up being the square root of 37 to 36 plus 1 dt. So over here, we're just adding, we're going to integrate square root of 37 dt. And so that's just going to be 2 square root 37. Yes. Brilliant. Absolutely smashed. Look for panels. I can't see. My bad. My camera's kind of crappy. We need to get a new one. So here we go. Next up, we're gonna go to velocity, acceleration, and speed. So R of t, R of t, some vector function. It's gonna be t squared plus t, then t squared minus t, and t cubed. Full. So I need to find the velocity, so v, a, and speed. So v of t is just equal to r prime of t, which is pretty straightforward. That's going to be, no, not 3. It's going to be 2t plus 1, 2t minus 1, and 3t squared. Great. These are vectors. A of t, it's going to be r double prime of t, or just v prime of t. So differentiating this is going to be 2 to 6t. And so then speed is some goofy v of t, and it is not a vector. And this is equal to the magnitude of v of t. I believe. So this is equal to v of t, or the magnitude of v of t. Do we need another point? It doesn't say a point, so we're just gonna plug in everything, I guess. So we're gonna take the square root of 2t plus 1 squared plus 2t minus 1 squared plus 3t squared all squared. There we go. So then if we gotta simplify, we can't leave it just like that. So this is gonna end up being 4t squared minus 4t plus 1 plus 4t squared minus 4t plus 1 plus 9t to the fourth, because 2 times 2 is 4. You will multiply the powers when they are exponentiated. So then these 4t's will cancel. These 4t's are going to be equal to 8t squared plus 1 plus 1 is 2 plus 9t to the fourth. And this is going to be square rooted. Cool. So Now we need to find and sketch the domain. Next step, we're going to finish this at 2.5 hours. Shouldn't be too bad. So we need to find and sketch the domain of f of xy, f of xy. This is starting the new fancy stuff, I think. Something. Excuse me. F of xy. That's equal to 4. I think this is beginning unit 3, maybe. X squared minus y squared. My polar brain is screaming r squared. Here's screaming negative r squared. And we need to find and sketch the domain of this. So, how do we find the domain? So, in 2D, we say we're going to look at the x values. Which x values cannot exist? And the domain would be a number line with circles and solid things saying, like, for example, if the function was f of x, I'm gonna kind of, in the spirit of this question, to kind of put me in the right direction, say f of x would be 4 minus x squared. Then the domain is gonna be, we cannot have x be greater than 2, because if x is greater than 2, then we have a negative number, so it can be 0, so x is less than or equal to negative, is less than or equal to 2, because then it would be, so even if it was negative 50, well actually, oh, it also has to be less than negative 2 for this one, because if it was negative 50 squared, then it would be negative. So x has to be between negative 2 and 2. And so that would be, you do the number line. We're going to do a two-dimensional thing. So z is equal to 4. So z is going to be equal to this. And so my brain is telling me to square it. So I guess I will do that, I think. No, wait. I was trying to find the domain. We're trying to find a domain. We're not doing anything else. We're trying to find the domain. So when does this not exist? This does not exist if this part with inside the radical is 4 minus x squared minus y squared. This must be greater than or equal to 0. That is the domain. The domain is when 4 minus x squared minus y squared is greater than 0. Cool. So then we can say x squared plus y squared is equal to 4. Just shifting everything over. That's also the domain. So if this is also the domain, then we can sketch this. So we know this is going to be a circle. Boom. X, Y point. This is going to be 2, 0, 0, 2, negative 2, 0, 0, negative 2. This is a circle. Brilliant. So we got to test inside. No, no, no. We try to make sure this is 4 is greater than x squared, y squared, not equal to. So if we said 0, 0, this is gonna be 0 squared plus 0 squared is less than 4. That's true. So that means everything inside is part of the domain. Happy, happy, happy. So then, what about something outside? So 3, 0. That will be 3 squared plus 0 is less than 4. That is not true because 9 is not less than 4. This is not true, so that means the outside is not shaded. All right. So we are about halfway done with what we're going to cover. We're not going to cover vector calculus. I might do one or two problems. Yep, the function f of x, y 2 minus x squared, y squared. Cool. That's all it does. So that means this is z. F of x, y is going to be z. So, wait, minus y squared. So we're going to do what we did before by sketching things based on the axes. So if we said xz 2 minus x squared, that's going to look something like this. So this is going to be 2, 0. And this is going to be 3, no, this is 0, 2. This is going to be 3, 0. Because that x is equal to 3, we're going to ignore the y. That x is equal to, this is going to be, gosh, my brain is not brain. So here, if we want z to equal 0, so 2 minus x squared is equal to 0. We're going to add 2 to both, add x squared. 2 is equal to x squared. That means x is equal to square root 2. So this is going to be square root 2, 0. The same thing for y, c, 0, 2, and this is going to be square root 2, 0. And so then when I sketch out the 3D, we can just kind of flunk these two together, and it's going to basically end up being the same thing. Uh, so we're going to have a circle, because it's going to end up making a circle. So this is going to be at z is equal to 2. So this is x, y. I think it was the third test, and we basically had to draw a diagram on every question. So this is going to be so lovely. So this is also square root 2. This is square root 2. And so then we're quadric. And then close enough. And then if we looked at x, y, that's x, y. It's a circle. I don't think you can see it, but it's not relevant. But it is relevant, but it's a circle. And I guess we technically could draw all three traces. Kind of hungry. There I go. All right. Find the limit. I can do these. Oh, I thought the two pack rule was on the third test. Okay. Hmm. Fine. All right, over here. On the limit. X, y goes to 1, 2, 7 x cubed minus x squared y squared. And then we're also going to say the limit as xy goes to 0, 0 of 6x cubed of y over 2x to the fourth plus y to the fourth. Okay. So this first one is pretty easy. We just plug in values because there's no indeterminate form, so it's going to be 7 times 1 cubed. Minus 2 squared 1 squared, which is going to be equal to 7 minus 4, which is 3. Yeah, okay. Now this next one. So this one I see plugging in values are going to get 0 over 0, which is not good. We don't like 0 over 0, 0 over 0 is bad. So we're going to come to 0, 0 by approaching along uh, x is equal to 0. So if we're So x is equal to 0 is this line. X is equal to 0. So if we're going to go along x is equal to 0, so this is going to be the limit as x, y, well, so x is equal to 0, y is going to go to 0, because we're going to go from original down. So limit as 0, comma, y goes to 0, 0. So this effectively becomes one limit, because this is already, or a single variable limit. Because now 6 times 0, it's going to be 0 over 0 plus y to the fourth. But because it's not 0 over 0 technically, I think we can just call this 0. That's kind of how that works. Because 0 is already in the numerator. Because 0 is already in the numerator, because it's 0, and we just ignore the bottom. Basically. Yes, there's this, which is going to approach 0, but it is not technically 0. So this function is going to end up being 0. And it's going to be similar for 0, and or for the other way around. So we're going to try another path. And so when you have these 0 over 0 things that approach 0, the typical thing you want to do is to put one function of another function and have the powers be the same. So if we said, like, let's try log y is equal to x. So then we plug in, so then it'll be the limit as x comma x, because it's y is equal to x, so it's not xy. X comma x goes to 0, 0. This is also effectively a single variable limit. So this is going to be 6x to the fourth over 2x to the fourth plus x to the fourth. So 6x to the fourth over adding these two together is going to just be equal to 3x to the fourth. The x to the fourth will end up canceling because limits. And so this is going to end up being 6 over 3, which is 2. And we got 0 from this one and 2 from this one. And guess what? Fools. Guess what? 2 does not equal 0. So that means the limit does not exist by the two-path rule. So that's pretty cool. Next up. Ooh, derivatives exciting. It's kind of sad that I'm not reviewing vector calculus in the stream, but if I can get everyone watching to subscribe, maybe I will tomorrow before exam. Anyways, f of x, y, otherwise known as z, is equal to 4x squared minus 2x cubed minus, not minus, multiplied by y squared. So we want f sub y and f sub xy. Those are the two things the question asks for. So let's first say f sub y. X is a constant, so this is going to be 0. X, we're going to slap it on at the end. Taking the derivative of 2y squared with respect to y, it's going to be 4y. And then I'm going to slap on the x bit at the end because it's all multiplied. It's a constant. So let's say x cubed. So then we need x. So that's f sub y. We need f sub x. All blocks is f sub y. F sub x, where it's not technically the answer, but we still have to do f sub xy. We could also do some fancy theorems by saying, yeah, let's do that. Let's do that. I did it the other way on my test. Well, let's do fancy theorems. So f sub xy is equal to f sub yx. So then you just differentiate this with respect to x. So f sub xy is just going to be equal to f sub y sub x. So then you just differentiate this one with respect to x. So the 4y is a constant that we're going to worry about later. So this is going to be 3 times 4 is 12. X squared, and then there's left the y at the end. Which is the same, oh, negative. The same thing we got on the test doing it the other way. Claro's theorem, baby. Gonna depends on how I'm feeling if I want to do a live stream tomorrow. Alright. Alright, fools. 2 more questions for this test. Find the equation of the tangent plane. F of x, y is going to be equal to 2y squared minus 2x squared plus x. And then we need to find 2, -1, and -4. Cool. So we want the tangent plane at that point. So I'm going to assume that this is a point on there. So if I'm just going to assume that it is. So if I plugged in 2 and -1, I guess we get -4. Okay. So we need to find the equation of the tangent plane. So the tangent line, scale it back. We have This is just uh, y is equal to x squared plus 1. Then we do a tangent line that this is x is equal to 1. So x is equal to 1. Y is going to be equal to y prime is 2x. And so the tangent line here was, let's see, just y prime of 1. Or let's make this more general. So this is x naught, this is y naught. And then, so why I'm making this general is so that I can just generalize it to 3 dimensions. So this is just y prime. So the line is y prime of x naught, right? Y prime of an x naught plugged in x. Yes, y prime of x naught. So the equation of this tangent line, let's try and work that out so we can figure out this thing. So the equation of the tangent line, uh, y minus y1 m times x minus x1. So the line is just going to be so n is just y. So y equals mx plus v. M is y naught of, or y prime of x naught. So this is m. So x, that's going to be x minus x1, which is this like 1. So for x naught, so here it was 1. And then plus b is just y naught, right? So plus 2. Well, yeah, if we said at the point 1, 2. So b, so y is equal to 4. Would be, it would just be 2x. 2x plus 2. Probably true. From this. For plus b, or you'll also call y naught. Let me go to Desmos and see if I actually did all this right. X squared plus 1, and then we're going to say 2x. Oh, it's so the y naught, it's is tangent at 1, 2? What if that y is equal to 2x? Um, hmm. What am I doing wrong? So x minus. So let's change this up. So we said. So this is m. This is x, and it's not really v, but so we're gonna erase this. So y is equal to the slope. It's gonna be 4. No, that's 2 times x minus 1 plus 2. So that's a 2 times x minus 1 plus 2. 2 times x minus 1 plus 2. That also works. So if we write it in this form, the equation of a plane, of a tangent plane, in 3 dimensions is going to be so z here we go, z naught plus f sub x of x naught y naught times x minus x naught plus f sub y times x naught, or of x naught y naught times y minus y naught. So then this is -4. Let's find f sub x. F sub x is going to be equal to -4x plus 1. Uh, f sub y, 4y, -4 plus f sub x of 2 -1. Right. So f sub x of 2 -1. Oh, whereas it's going to be -7. So -7 times x minus uh, x naught is 2 plus f sub y is 4y, so 4, and then we're not gonna look at x. 4 times -1 is -4, so say -4 times y minus y naught is -1, so -1 or plus 1. Is that right? I check. Watch me derive this during the final. -4 minus the next master. That's cool. So this is kind of conjoined with next. The tangent plane is so much linearization. So it's basically the same thing. Uh, It's trying to be real. I'll look at other people's be reals after the exam. Not after the exam, after I'm done. So linearization and tangent planes are very similar. So I'm gonna quickly review it to try and make sure I get it. So L of xy is approximately equal to xy at the point. So if you find the tangent plane, it is and then you can plug in values x and y. Okay, that seems fine. Taking a couple of shortcuts, but it's like because I am hungry. So this next question during the test was a nightmare for everybody, but and it was literally just chain rule. So I haven't looked at it in a while, so we'll see. So we have 2, 3, and 5, 7. So x and y is 5, 7, and 13, 44. F, G, -2, 6, 5, -2. Um, F sub x is 3. F sub y is -4. This is 3, 2. So this is kind of like a table. And we have G of RS is equal to F of 4RS, 4R minus S, comma S squared minus R, and X is also a function of RS. So X is equal to 4 R minus S, and Y is equal to S squared minus R. Then we need to find GR of 2, 3, and G of S of 2, 3. This is a lot to unpack. I think you're light. It's not much light, I'm gonna be honest. So the little tree diagram says we're gonna take so this is a function of g, so we're going to say g. You break it down into x and y, and you break it down into r and s. Well, g g of r s is just equal to f of x and y. Because if GRS is equal to f of, yeah. So g of rs is equal to f of x and y. We define g sub r and g sub s. So we could say, so we're really not looking at g, we're looking at f. So, so f of f sub r of 2 and 3. Well, just f sub r of x and y. Um, so, or let's not d f dr. So you break it down into two little addition thingies. So we're gonna say df dx and dx dr plus df dy d y dr, not dy dr, dy dr. So then these will end up canceling out and it's df dr. All right. Next up, we have this. This is df dr. Well, if we have df dr, but we need g of r. So we have everything in terms of f, really. Um, so so if we said g of two, no, f of 2, 3. We're not looking at 2, 3. We're looking at 5 and 7. Is that the point 2, 3? That's kind of goofy. What? Wait a minute. Um, so here, g of 2, 3 is what we're gonna look for. So we need to find what is f at that point. So g of 2, 3. Oh wait, we need to just plug in values, right? So 2 for r, because these are r and s values. There we go. So this is r, 2 times 8, or 2 times 4 is 8 minus whatever s is, which is 3. It's going to be 5. So it's going to be 5. Um, and y is s squared. So s is the second, so that's 9. minus r, which is 2, so 7. So that means g of 2, 3 is going to be f of 5, 7. Okay, okay. So then, so if we have df let's say at 2, 3, at 5, 7, this is going to be equal to gf, dg, dr at 2, 3. There. So now df dx. So, so differentiate. So df dx. What's df dx? Well, dx dr is going to be 4. 4 y sub r is going to be equal to -1 x sub s is equal to -1, and y sub s is going to be equal to 2s. So we're not doing s is equal to r's. So this is going to be a 4 times something plus something times d by dr. That was -1. So now what is df dx? So this is x. This is a y. So this is f of x and y. Oh wait, we got the freaking table. Okay, f sub x at 2, 3, we're looking at 2, 3. It's gonna be 3 plus f sub y at 2, 3 is gonna be -4. So this is gonna be at 12 9. Is that -4? Wait a minute, wait a minute, wait a minute. So we want the table version of 5, 7, right? Yeah, not 2, 3. I am so. So that's still 12. This is going to be 2 times -1, which is going to be -1. -2 equals 10. And then df ds at 5, 7 is equal to dg ds at 2, 3, which is what we're looking for. df dx dx ds plus df dy dy ds. Okay, so here df dx at 5, 7 is 3 times dx ds, that's -1, plus df dy, or f sub y, is 2. And then dy ds, it's going to be 2 times s. S is 7, right? It's rs. Is it 7? I mean, technically, what we're doing is dg ds at 2, 3. We're just comparing it. So if s really s is really 3, is s 3 or 2? I know, is s 3 or 7? S at okay, if we wanted to work this out for dgds, this would be 3. So I'm gonna say it's 3. Okay, so that's -3 plus 12. 9. Okay, that's so cursed. Questions? Not this much. What time is it? Okay, we're good. Finally, so here f of x y is equal to x squared y to the fourth. And the direction for that one. And b. So we're going to find the gradient of the function and then find the directional derivative. So the directional derivative, so the gradient of f sub x, f sub y as a vector, and then g f u is the notation for a directional derivative or unit vector derivative or whatever it's called. So it's going to be the gradient of f. Is it just dotted with u? That sounds right. Yeah, because you gotta combine them somehow. So f sub x is going to be equal to 2x y to the 4. F sub y is going to be equal to 4x squared y cubed. So the gradient of f is going to be 2x y to the 4th comma 4x squared y cubed. And this is at 1, 1. So let's just, so the gradient of f at 1, 1 is going to be 2, 4. There we go. Great. 2, 4. And then u, we need to find u because we don't have it. So the unit vector is equal to the vector over the magnitude of the vector. So that's going to be 4, 3 over 5. Because it's just 16 plus 9 square root. That's 5. So this is going to be equal to 4/5 and 3/5. Okay. So we're going to say 2, 4 divided with 4/5, comma 3/5. So that's going to be 8/5, comma 12/5. Oh wait, you add them together. So the dot product after all. So that's going to be equal to 20/5, which is 4. Dot products, remember. All right. Sure. No. This one should be super quick and easy. How many questions are there? Gosh, there's a lot of questions on this test. Okay. 1, 1 is a critical point. Okay. And so f sub x at that point is equal to -4. F sub x y is equal to 1. F sub y is equal to 1. Fair, I'm just going to start right. Is equal to -2. And so so we need to first find d, and then compare it to. First we got d, so that is x y f sub x y squared minus f sub x x f sub x y f sub y y. f sub x, x, f sub x. No, y minus f sub xy squared. So this is -4 times -2 minus 1 squared, which is greater than 0. And so then it's not a saddle point. The x-axis is negative. So that means that it is maximal. So it is xy minus xy squared. Okay. Yep. That's thing to note. So then we need to find the absolute maximum. So we have this curve. One, here's one, 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 there's one. Cool. That's curve and 1 plus x squared y. We're going to find absolute maximum. Alright. Absolute maximum. Absolute maximum. So I said I'd do all of this, but I think I might do this last. And then I'll do vector calculus too. But I am so freaking tired. I got up so early. We'll just review the second half of calculus 3 tomorrow, I guess. I don't know when I'm gonna do it though, because I don't know when I am able to. Unless I want to do it from like 7 to 9. I don't think I want to do that. You know what? If I wake up before 7, I'll do it from 7. If I wake up before 7:30, I'll do it from 7:30 to 9:30.